Hello and welcome to our webinar, 5 Quick Wins for the Cloud. Thank you for joining us today. Before we get started, we have a couple questions for you. So we're going to go ahead and launch a few polls. So just take a couple minutes. The first question is, are you using the cloud today? And so we're defining cloud as infrastructure as a service, so meaning Amazon EC2 or Rackspace or maybe even private cloud. So these options, just select the one that applies most to you. Yes, you're in the cloud and you have several real projects. Yes, you're in the cloud, maybe just one project, but it's growing. You're just beginning to explore the cloud, or no, you're not in the cloud yet. So we'll leave this poll open for a few more minutes, or just kidding, a few seconds. That'll be a long time. And then, okay, we're closing the poll. We'll share the results with you. And cool, there's a broad distribution here of people who have a lot of experience, people with some experience, and then people who are just starting to explore and learn. So that's great. Today you will learn a lot that will help you on your exploration. Next question. If you're using the cloud, are you using cloud management? So a couple options here. Yes, you're using cloud management direct from the cloud provider. So using tools like Amazon's console, for instance, that would apply for that first option. Yes, you're using cloud management. Maybe you're on RightScale. Yes, you're using cloud management, but from another third party. No, you're not using it, but you're exploring, or just simply no, you're not using cloud management. You're not using the cloud. Leave this open for a couple more seconds. Interesting. Okay, this is actually really in line with what I was expecting. So for those of you who are using cloud management, the majority are using direct from the cloud provider. So that's interesting for you today. You'll learn a lot about how cloud management can actually help you with your cloud deployments. A couple of you are using RightScale, so thanks to that person in green. And then several of you are exploring. Cool. So we'll close this one down. Final question, and then I will leave you alone. So what is your role? Just select one here, application developer, sysadmin, architect, or this final one, team lead business manager, is really for the non-technical crew who's joining us today. So this helps us understand what our audience is comprised of and maybe what your specific roles and focuses are, and then really helps Brian and Rafael with adjusting the tone of the content. Cool. And then about, half of you, it's evenly divided, half technical, half business audience. So thank you again for this, and we're going to go ahead and get started with the webinar. So close that down. Show you our pretty intro slide, click through to our panel today. So on my right, I have Brian Adler, who is our professional services architect. Some of you may know Brian. He's spoken at several cloud computing industry events and works closely with our customers every single day on figuring out their cloud deployments and helping them create their cloud architectures. And then on my left, I've got Rafael Saavedra. He's our VP of Engineering at RightScale. And for those of you in the audience who have been to our RightScale user conferences, you may have seen Rafael and some of his really popular presentations on managing RightScale and a couple other things that are really interesting. I also have Will Eschen, who's our account manager. He's manning our Q&A channel. So you can ask questions at any time throughout the course of the webinar. Will be answering every single one of those as they come in, but also a few of those questions we'll be selecting and having Brian and Rafael answer live on the air. So throughout the course of this presentation, again, just feel free to answer your questions, and ask your questions, and we will do our best to answer those as quickly as we possibly can. So with that, I'm going to hand it off to Rafael. Thanks.
Thanks very much, Sarah, and welcome to this webinar. So I'm going to review the agenda for today. So the title of the agenda is 5 Quick Wins on the Cloud, and here are the 5 that we're going to talk about. The first one is development and test. The second one has to do with configuration automation of deployments on servers. And then we're going to follow with monitoring and alerting. And then we're going to pass and talk about auto-scaling architectures. And the last one is going to be how to architect high availability deployments. Then after we review each of them in some depth, we're going to try to summarize everything with some takeaways. And after that, we're going to have a session of questions and answers. But I just want to remind you, as Sarah said, if you have any questions during the presentation, please send us the questions and we're going to try to answer them. So I think before we start with the first quick win, we would like to find out which of these areas are the ones that you are most interested in, and we're going to try to tailor the talk and maybe spend more time in one topic versus another one. So we're going to go to another poll, the last one, I promise. And in this one is which cloud big win are you are the most interested in? And you can select as many as you want. And again, it's development and test, configuration automation, monitoring and alerting, auto-scaling architectures, or high availability architectures. So we're going to give you a couple of more seconds for all of you to answer. It seems it's still moving around. But it seems that it's just changing, but probably it's going to stay that way. So maybe we can close it. I'm going to share the results. And it seems that you are interested in all the topics. Some of you, maybe multiple of them, but it seems that all of them are interesting to you. So that's good, because I think it fits very well to our presentation. So we're going to start with the first one, and I'm going to pass the mic to Brian.
Great. Thank you very much, Rafael. And as Rafael mentioned, our first one that we're going to talk about here is development and test. And in the role that I play in professional services, a lot of customers that I talk to, obviously the vast majority of them are bringing production workloads onto the cloud. But a lot of those customers also have the need for development and test environments and QA environments and staging environments, a lot of other environments to help assist them as they move towards production. So it doesn't matter if you're an enterprise customer or you're two guys in the garage with a credit card and the dream. You generally have a need for some sort of development and test environment. So we'll talk a little bit about how the cloud and how RightScale can help you in those regards. A lot of companies, RightScale included, are using sort of a more agile software development methodology, right? And sort of the diagram, the little image at the bottom is kind of showing that compressed release cycle that you probably are familiar with. And the market forces that drive that you probably are familiar with as well, is these shorter release cycles in this more agile environment, and you have these folks all over the country or all over the world that are participating in your development environments. And you need to have some way to have them able to do their development and test in an efficient manner, and also to be able to deploy their code, to be able to test that code in a quick and efficient mechanism as well. And that's more of a big win, or sorry, quick win number 2 that Rafael will talk about, but we will at least touch on it in the development and test section as well. So the lifecycle challenges, what you see here in blue is sort of the, in a perfect world, the flow, right? Obviously there's a lot of loopbacks here. You're going to do development and test, you're going to find some problems, you're going to go back to development, you'll get to QA, they'll find some problems you didn't find, it goes back to development, etc. But sort of the perfect flow, right? We go development, test, QA, staging, and then eventually into production. Now the problem in the classic data center model is that we have these limited shared resources, right? You've got this fixed set of servers and everybody wants to get time on them. You've got these different teams that need to get different time. You've got your developers, then you've got your QA folks that need to test. Well, they're going to have to do some time sharing, right? And you got the folks that get the 4 a.m. shift, and they're more apt to make mistakes and maybe blow away portions of the environment. That environment needs to be recreated either from a backup or manually, or just this whole time sharing of these limited resources has been very, very difficult. You can always add additional resources, but that's costly, and also there's a huge lead time, right? In the old data center model, it could take weeks or months to be able to get access to that new infrastructure. And with these geographically dispersed teams that you want to be able to have consistent environments so that if someone blows something away, it doesn't affect others, and you want to be able to bring that back to a pristine state very quickly. And you also want to have multiple environments in parallel so that you can have your development guys working on one environment. You have your QA guys maybe testing the code that you're hoping to put in production shortly. Maybe you have another environment with people doing fixes on an existing branch or something like that. So you want to have these multiple environments. And that can be challenging, obviously, when you have these limited shared resources. So that's kind of where the cloud comes in to be a perfect fit, right? The graphic you see here is from a poll that was a market poll that was done a while back, and kind of asking, hey, customers, what are you looking to use the cloud for? And not surprisingly, scalable website was first and foremost. And that makes a lot of sense, right? Let's use these dynamically allocatable resources that we have there to be able to handle viral loads, viral events, flash mobs, that kind of stuff. But second, and not a very distant second, was test and dev. And why? Well, it provides this IT and business agility, allows you to spin up resources quickly when you need them, and to make better use of them. You see a bullet point there talking about most test servers in a classic data center environment run at less than 10% utilization, right? So you're paying to run those servers that are doing nothing, and they're heating up a room that you're paying to cool that are doing nothing, right? So in the true pay-as-you-go utility model of the cloud, you can now spin these servers up, test on them as you need, and when you're done, you flip the light switch off and you stop paying for them. So what we're kind of showing here is the sort of the available resources, right? That's the resources coming from your cloud infrastructure provider, whoever they may be. Amazon EC2 or Rackspace or a private cloud running Eucalyptus or Cloud.com or OpenStack or whatever your flavor may be, right? You've got these available resources that you can get access to. And by using the RightScale or any provisioning and configuration control, but obviously we're going to talk a little bit about our particular flavor of it, by using these provisioning and configuration control mechanisms, you get all the happy things you see there on the right, creativity and improved quality, etc. But probably most importantly is you get the faster time to the customer and you get a higher utilization of the resources, both the human resource as well as the server resources. So you're saving money and you're not wasting money, right? And again, provisioning and configuration control is a big part of this, and Rafael will talk about that in quick win number 2. And sort of lastly, in the dev and test thing, what we want to show here is that we have what we call our all-in-one, the LAMP all-in-one, for example, our Linux, Apache, MySQL, and PHP all-in-one server template. And there'll be some information in the takeaway section at the end about how you guys can get access to that. But basically, that's of great use to developers. They can spin up their own little world, right? They can have everything they need running on a particular instance that's their own little instance. They can do whatever they want to it. If they screw it up, they've only screwed themselves up. And if they do screw it up, with a simple click of a relaunch button, they can bring it back up to a pristine state using our server template and RightScript methodology, which again we'll talk about here shortly. Now you also have the ability to break these out into multiple tiers. Now granted, you're not going to run in production on a single server, so what we have is we have the same concept of we have server templates that break out all the components of the all-in-one into multiple tiers. So like your load balancers, your app servers, your cache servers, your databases, etc. And what this is showing here is that you have the ability to show to your users exactly what they need to get access to. So you can have server templates for the load balancers and the app servers, etc., that can be used by your testing environment, and those exact same server templates are going to be used in your production configuration. So that if you launch something in your test environment, you know that when you launch it in your production environment, it's going to look and smell exactly the same because it's based on the exact same server template. So it allows you to kind of go from that dev and test all the way up through to production using this sort of the same single pane of glass and the same user experience, if you will, as you go through this. And again, we'll talk more on the all-in-one templates in the takeaway section, but this is probably a good segue into the second big quick win, which is configuration control. So I'll hand it back to Rafael for that.
Before I start with the next section, there is a question that maybe you would like to address, Brian.
Sure.
Someone asked, what do you mean by grid computing?
By grid computing?
Yes.
Oh, okay, great. Well, I didn't mention grid computing, but that's a great question anyway. So grid computing, we have, so you can think of the grid computing, a common use case is folks that are running batch jobs. That's probably the most classic example, but we have other customers that are doing similar things as well. But you may have a great example of some of our customers that are in the biofarm industry, if you will. They're doing FDA number crunching, right? They have to do FDA compliant stuff, so they have to do number crunching on their data. This is something they do very infrequently. When they have a big set of data, maybe they need to do it once a month, once a year, whatever it may be, but it's a lot of data to be crunched. So using what we have, something called, it used to be called RightGrid, it's now been renamed our Grid Computing Solution Pack. I'm looking at our marketing folks to make sure I get that right, because when the names change, I get confused. But basically what that allows you to do is to take that workload and to run it in this grid environment where you spin up individual servers to handle individual tasks, and you can configure how many of those servers you want to spin up based on the length of your queue, or maybe you have an SLA. I don't want any job to take more than X minutes, so you can do something like that.
Thanks, Brian. So Brian talked about this hierarchy of systems. That basically it can start with a single server, then goes to a multiple server, maybe for testing, and then it goes to a full-blown deployment. So the question is, how do we configure all these systems and how do we maintain them in a consistent way? So that's the next topic, that is the configuration automation. And the idea is that we should be managing systems and not servers. That helps in improving productivity and also creates business agility. And the idea is that we package all the servers that work together, maybe as a logical collection, in a concept that we call deployments. And the benefits of having a deployment is that, well, first of all, you can manage all of them on a single page. You can execute operations on all of them. You can, for example, update the code, or you can do a backup on all your databases. So having these collections in deployments has benefits. In addition, you can also do some kind of access control into the deployments, so they can use different server templates. You can monitor in different alerts and having different escalations based on the actual deployment. And then once you have these logical constructs, you can clone it easily. So if you need to, for example, you want to put your application in a different cloud or in a different region, maybe you are in the US and you want to move to maybe Europe, it's easy to clone, and then it's very, very convenient to just change the configuration parameters that allows you to probably point to a different DNS provider and so on. So in this case, the idea is that the notion of a deployment is very powerful. In addition, something that it's orthogonal to this, but helps, is what we call server templates. And if you are familiar with cloud computing, probably you have launched servers using images. And an image is a very convenient way. It's if you want to launch a small number of servers, because, well, you have an image that packages everything that you need to configure the server that you want, and then you can just click a button and suddenly you have a new instance for that image. The problem is, once you start growing into a complex system that may be tens of servers or maybe hundreds of thousands of servers, the problem is that, as Brian mentioned, these systems go through an evolution. They change over time, and trying to keep tabs on what each image is doing and making sure that all your servers are running the same kind of software, have the same patches, and also all the security changes that are required becomes a challenge. So for that reason, we at RightScale identified very early that we needed an abstraction, and that's what server templates are. The idea is to have something that is modular and flexible, as opposed to be big and opaque as the images. And modular in the sense that it's easy to configure new servers by just changing, like Lego pieces, small components, when each component configures a specific aspect of the system. For example, it may be installing MySQL. That's a modular component. And if you want a server that is going to install a database, and in addition is going to install maybe a piece of software like Rails, well, what you need is to combine these two different components. But then if you want to break your server into multiple servers, maybe one running your application with Rails and the other one running your database, well, all you have to do is to create two server templates and reuse the components and just use the Rails in one and the database for the other one. So that allows you to have a very dynamic environment and to be agile. And in addition, now that there are multiple clouds and also multiple regions for the same cloud provider, you want to easily move from one cloud to another, or from one region to another, and server templates hides all the details that you will need to do with images in moving from one cloud to another one. So that makes it very portable, makes it very powerful, and also it tends to flow the dev-lab workflow that most people, developers, follow.
Hey, Rafael, can I jump in here with one quick question there? It's a good point, is that we kind of use some nomenclature that might confuse people, and we apologize for that. We had a question about what does MCI mean. So basically that's our multi-cloud image, and what that is that's an abstraction. For those of you that are familiar with the way the cloud works in the different regions, the same as Rafael alluded to, you might be familiar with the AMI concept in Amazon, for example. An image that you run in US East is not going to run in US West. Well, we have the concept of a multi-cloud image, which abstracts that for you so that you can take the same server template and run it in any of those regions or any cloud. You can run it in Rackspace as well, or Cloud.com or Eucalyptus, and we'll take care of the multi-cloud images. Sort of rides on top of all the underlying images that allow you to increase or allow you to do that cloud portability, if you will.
Just adding, imagine the complexity of saying, okay, I want to run my application maybe on Amazon, but also I would like to run my application on Rackspace. And I need a CentOS 5.4 with a certain configuration in both of them. well, it becomes a nightmare to make sure that the images that you have in one cloud are exactly the same as you have in the other one, because maybe in disaster recovery, you need to, in a matter of minutes, relaunch your servers and make sure that everything is the same. So the idea of a multi-cloud image is that it abstracts that notion so that you don't have to worry about the details, and we at RightScale make sure that when you launch a new server, you're going to be using the same image. Okay. So what we mentioned that is essential for server templates is the idea of these modular scripts. And it can be scripts or recipes if you are familiar with Chef. And let me just try to highlight something here. Yes. So, oops. So the idea is that you have this collection of scripts, and the scripts are just small recipes, a small set of instructions, and we basically break them into four pieces. One is scripts that you run at boot. That is, when you launch your machine, you say, okay, in order for this server to be configured, these are the scripts that need to run, so that at the end, when the server becomes operational, all the software has been installed on the machine and is ready to operate. In addition, during the lifetime of the server, you may need to do certain actions on the server. For example, you may need to upgrade the software. You may need to take a backup or maybe do a restore of the database. Well, those are your operational scripts. And in addition, you have the commission scripts, and these are the scripts that you want your server to execute when you are shutting down the machine. For example, if there is a database, you may want to make sure that you take a backup before you completely shut down the machine, so that you have a complete a snapshot of the state of the database at the point of termination. Now, these scripts sit on top of the base machine image, and the idea is to use as an image something that is very simple, very reliable, that only have the minimal components that allows you to know that this image works exactly the same. It doesn't matter what service is going to be on top of that. And that is the scripts who are going to configure the server to do a particular action. Here is an example if you want something concrete about what is a server template. And as you can see, it's a LAMP all-in-one that is also running MySQL. And the boot script is just a collection. Here is something between 10 and 15 scripts. And each of them is doing something very simple. For example, it's configuring the time zone of the machine, or is installing the software that is going to send the login output into our servers. And then it's going to go and try to install MySQL 5.5. It's also going to do some configuration so that we can load the database. And then, because it's all in one, we also need an Apache web server. So we're going to do the installation. We're also going to need PHP. So we have also another script that does that. The nice thing about this is that if you want to construct a completely different server template, maybe something that it only has a MySQL in it, all you need to do is to take these small scripts, combine them, and produce something that is the same. What's important is that these scripts are version controlled, so you know exactly which version are they running. For example, here is revision 18. So if you find problems on one of your servers and you want to revert to a previous configuration that you know is stable, it's as easy as just opening the server template and changing the revision to something that you know is going to work. And in addition, you can see here the operational scripts. And in this particular example is you would like to do a backup of the database, or you would like to restart your Apache. So normally these are the normal operations that you will do. And
Rafael, let me interrupt you here before we go forward, just to answer a couple quick questions that have kind of come up as you've been talking about this. So the first one, actually, I'm going to let you answer because I'll say yes, but I need you to caveat it. So the question about OpenStack support, are we going to support OpenStack in the near future?
Yeah, the answer is yes. And we are currently working on supporting that. We are actively collaborating with them in the Diablo 3 and Diablo 4 releases, but the answer is yes.
And one other one here real quick is the question on what is RightLink. We had RightLink mentioned on the previous slide. You want to go ahead and take that?
Yes. RightLink is a small piece of software that we install in all our images that allows the servers, once they're operational, to communicate with the RightScale infrastructure so that, for example, if you want to execute operational scripts, that's the efficient way of doing that. Something that we're working currently and we see a lot of potential is the interaction of servers, that they can collaborate with each other so that, for example, one server can trigger an action on another server, and it may be, we're going to change the HA proxy. Please, all the application servers need to connect now to a new HA proxy. And this communication between servers is done efficiently through RightLink.
Great, thanks, Rafael.
So the importance about server templates is that once we start creating these, we can also have a library of server templates, and in RightScale what we have is what we call the marketplace. And the marketplace, as you can see here, is just one page. An example is you can browse them as a user of the RightScale dashboard, and you can see the contributions coming from RightScale or from other users, customers, or maybe partners, or users like you. And you can see examples, for example, a database manager for MySQL 5.1, and here it tells you that this server template is ready and it works on Amazon, Rackspace, in Cloud.com, and also Eucalyptus. And another one here, the base server template for Windows, well, this one runs on Amazon or Rackspace. The important thing is that all the details about how to configure all this particular server for each specific cloud is taken care on the server itself. So by just importing this server template into your account and having a real account on each of these clouds, you can launch this server and you can guarantee that it's going to go to operational once you have basically entered the right inputs. In addition, you can browse examples from other contributors, so you can learn from their experience, and you can diff the different server templates so you can see changes as they evolve over time. So this is a very powerful abstraction. Then, so how do we start? If you want to start writing a server template, how do you do that? Well, the easiest way is to do the same thing that you do to configure a server. That is, launch a simple write image, and then go into the server and try to configure the server as you normally do. The only difference is that as you're doing that, you want to record all the steps into a script. So for example, you say, okay, I would like to install Python, and in order to start Python, I have to run these commands on the server. Well, do that, make sure that it works, and once you have that, create a write script that is going to capture those steps, and now you can give a name that says installation of Python. And you can give it some version so that you know exactly what version of Python you're installing. You may have to add some attachments if you need a file that has to be installed and has to be downloaded. And now you have your component that is doing exactly what you want, and then you can combine it with other write scripts and start creating the server templates. So the key here is to have consistent, reusable configurations. And the way it works is that normally you have your architect that is going to provide a reference architecture, and then we're going to use this one to create different deployments of different complexity for different purposes. And maybe for development, it's going to be an all-in-one, very simple one that only contains an app server and a database. But maybe for testing and QA, we're going to add it to have a multi-server deployment that's going to have a load balancer, multiple app servers, and databases. The idea is that the time spent in configuring the server template for development, well, once the individual components in write scripts and recipes have been written, can be reused and just complemented by new ones, in this particular case for the load balancer. And once we have these running and working correctly, this can also be passed to a staging and production, and we just extend it in any way we needed to do it. So that's a very powerful way of working. And here we're just illustrating that. These 3 steps can be instantiated into real servers, into something that is just one server template for maybe one server that can be morphed into 2 server templates for the app server and for the database, and maybe another one for the load balancer. And then with small changes, we can just clone them and modify them so that we have our production server templates. So it's a very convenient way of evolving this process.
Great, and then Rafael, before you jump on, we have a couple questions that are very pertinent to that particular section, so why don't we go ahead and address those. So I'll take this first one. It says, so EC2 and Rackspace have very different configurations that they offer in their cloud instances. How do you have one template that could work across both of them and guarantee that you have the same amount of RAM, disk, etc.? So the way that really works is you have the server template, and that server template can ride on top of any of these MCIs, and that MCI, as we talked about, is that multi-cloud image. And you can specify that server template to work with any of the instance sizes. So to give some examples, let's say that you were familiar with AWS and you're running your application server on M1 large, and you get 7.5 gig of RAM and 820 gigabytes of disk or whatever it may be. Now, granted, there isn't the exact same analog in Rackspace, so maybe you choose an 8 gigabyte server, which is a little bit more RAM, and I apologize, I don't know the Rackspace disk space allocations there as well, but what you can do in that server template, as you specify it running on one cloud or the other, you can specify the instance size that it's going to run on. So granted, you won't be able to map it one-to-one, but you could always find, let's say that the M1 large is your lowest common denominator. You could find the equivalent or greater, slightly greater if you will, that runs in Rackspace to ensure that you have the same basic response and same basic performance of that instance. And then one other one real quickly, Rafael. So it says, so Rackspace doesn't have a cloud block storage solution. Does this mean that you can't use block storage on AWS because that type of feature isn't available on all cloud platforms? No, it doesn't mean that at all, which is great. So what we can do is, with the cloud agnostic aspect of our server templates, we're going to take advantage of whatever features the cloud provides. So for example, if you are on AWS or you are on OpenStack D4 or whatever version it comes out when they have this concept of block storage, or you're on CloudStack with cloud.com, we can take advantage of the available block storage. And if you're not, if you're on a system such as Rackspace, which doesn't, then we'll use the available attached storage and use an LVM snapshot mechanism instead of an EBS. So you're able to take advantage of the features that the cloud provides, regardless of which cloud that you're on.
Thanks, Brian. So let me move to the next quick win, that is monitoring and alerts. And the idea here is quite simple, is, well, if you have a production system, you have all these servers running, you want to make sure that your system is up and running 24/7, and that you are alerted when something bad happens to one of your servers, or even before, when something is maybe reaching a threshold value that requires maybe an operator take some action. So one of the big wins about the cloud is that you can leverage all the infrastructure that cloud management providers like RightScale has basically created in the last 4 years, so that all your servers, from the moment that you launch it, can start being monitoring and provide information that you can't check, you can't see, and also you can't connect to alerts so that you make sure that your systems are running properly. So for example, we offer 80 default real-time metrics for compute databases, networking, load balancing on Linux and Windows. Some of these metrics are for CPU, disk, memory, network, and systems. Some others are to monitor specific processes. And then we have specific plugins for example, Apache or Microsoft IIS, and also for MySQL or SQL Server. So there is a wealth of information here, and it's a very convenient way of showing it over time, different time scales. For example, you can see it over a period of hours, maybe for a day, weeks, a month, or even up to a year. And in addition, you can have tiny graphs or make it larger so that you can see more details. So these are individual graphs, and each server that you are running, and let me just show you something like here, like in this particular case, I think, like here you can see there's a server that is running. Oh, this is not a running server, this is a template, sorry. Let me go back. So, but this is an example of what you will see if you have a server running that is, for example, running MySQL. You will see the behavior of MySQL for the disk, and it's something very valuable to monitor. Now, as you can imagine, these graphs are very interesting, but once you start managing tens of servers or maybe hundreds of servers, just monitoring a single server and looking at the graphs is not very convenient. In some cases, you may have a collection of, for example, app servers, and you would like to see all the behavior for all of them in a single graph. So for that reason, we have basically built on top of this infrastructure, and we have concepts that what we call cluster monitoring. The idea there is that you can aggregate a collection of graphs and manage them as if they were a single graph. And let me show you an example of that. And here is, for example, there are 8 servers. All of them are application servers. And we are looking at the CPU utilization for a specific CPU. In this case, is CPU 0. And the nice thing about using a concept deployment is that if you tag your servers using certain identifiers, you can say, please give me all the front ends and show them together so that I can compare them against each other, and I can see it, for example, in a time scale of a week, and I can look at them in a small graph. So that's very nice. So you can see, for example, that 6 of the servers have been running for the last week. All of them have some activity, and there is one that has a lower activity, and the reason because it's been used for testing migrations, and there is a new one that has been launched recently. So that's the convenient way of doing it. There are limitations because these graphs allow you to look at each individual server, but you don't see the aggregate contribution of all of them. So for that reason, we create another concept that is stack graphs. And the idea here is that you can display the contribution of multiple servers in a single graph. You can see the contribution of each of them by looking at different colors. And here's an example. It's at the same server that I just showed you, but now their activity is stacked together. So you can see that the aggregate contribution over the last days is pretty much similar, but it's much lower for the Saturday and Sunday. This is also a nice way of looking at the data in a different dimension, but there are also limitations. And some of it can be, okay, how can I compare the activity of this server against this server? Is this activity normal or abnormal? And for that reason, we have created another concept that is heat maps. And the idea of heat maps is to see intensity. So here's an example of the same servers. Now, this dimension, this vertical dimension, is taken by each of the servers. You remember there were 8 servers. One of them was just launched. Another one was lightly loaded. And you can see here that the blue color shows that. And then the 6 other servers have their normal behavior that during the day, during normal working hours, they are more actively loaded than during the night. And you can see that all of them behave in the same way, so there are not anomalies in that respect. So alert and monitoring connected with deployments, it's also very, very powerful. You can have graphs that are at the server level or at the deployment level so that you can see all of them in one place. Now, here's an example of 100 servers using a heat map. And these 100 servers, you can see that most of them behave normally for periods of hours, and then suddenly 6 of them or 7 of them start having some overload. So it's easy to see that something happened at 8 a.m. And the interesting thing is that you're graphing here 60,000 data points, and all the work is being done by RightScale on the back. So it's a very powerful tool. Now, once you have your graphs, you want to create alerts. That means you want to be alerted that something abnormal happened. In this particular case, probably you want to be alerted when these servers start to go red. So in order to do that, there is the notion of an alert that is just connecting one of the metrics that we're monitoring and saying, okay, if this specific metric, the value is less than a certain threshold, please, for a duration of time, please execute this escalation. The idea of an escalation is just a sequence of actions that is a response to whatever condition has happened. And I think I want to stop here because we want to move to the next topic, and that's autoscaling. So in autoscaling is I think maybe is one of the most successful applications in the cloud. The idea is the following. If in the traditional case, you are making an investment because you want to deploy maybe a new application, and you need to predict what is going to be the demand because you need to make a large capital expenditure to buy the resources. So the way it works is that someone is going to do some number crunching and is going to say, well, this is what we believe is going to be the predicted demand. Therefore, we're going to make some investments over time that is going to try to capture that required capacity. The problem is that before you even launch, you already make a big investment. And you have to basically pay for that investment until the actual use is going to catch up. Now, maybe at the beginning, your application is not going to take off as fast as you want, but you still are predicting there's going to be a big jump, so you have to do the next investment. The problem with that is that there is an opportunity cost here that says, if I could actually try to match my expenditures to the actual usage of the application, the actual demand, then I'm going to reduce my cost. Now, if you try to be aggressive and say, well, I'm going to wait until the demand tells me that I need to add more resources, well, you run the risk that if you're successful, suddenly you're not going to be able to catch up, and then you're going to have customer dissatisfaction because you have insufficient hardware. So in autoscaling is, let's do a very flexible architecture in the cloud that in principle has unlimited resources so that we can scale rapidly and try to track this demand as close as possible so that I can reduce my cost. And this is very simple, achieved by having what we call an autoscaling array. That is, normally you have your three-tier application, that is your load balancers, your app servers, and then your databases. And what you want is to have an array of application servers that are easily deployed so that they are connected to alerts, and these alerts are connected to escalations, and the actions of the escalations can be to launch new servers as your demand increases, or to basically terminate servers if your demand goes down. So that's, I would say, maybe the most attractive way of using the cloud. So if you want to deploy something new in which you have uncertainty about what is going to be the demand. And at this point, I'm going to pass the mic to Brian.
Thanks very much, Rafael. And this kind of all ties into our last topic, our last quick win. And sort of we try to build on from 1 through 5 here, sort of build a story, if you will. And what we've, again, in my role with talking to the folks, talking to our different customers, particularly in the last few months, there's been some cloud outages, right? They all probably are familiar with, starting with April and then a few since then as well. And as a result, we've had a lot of customers come to us talking to us about, hey, I need HA. And actually those cloud outages, if you will, we kind of think of them, in a way they were a good thing because it forced people to realize that, hey, I don't have high availability, right? These cloud infrastructure providers have done such an excellent job of providing continuous service that I kind of took it for granted. Well, what we're realizing with these last few months is that everything fails, right? So you have to plan for it. So what we're going to talk about next is sort of our general HA best practices, and then also in the next 2 slides I'm going to show some pictures of what we generally talk to customers as far as an highly available and a disaster recovery. You hear me talk about HA and DR, and if I don't spell those out, I apologize. But HA is high availability and DR is disaster recovery. So the next 2 slides will show pictorially what we're going to kind of talk about here. But our general HA best practices. Avoid single points of failure, obviously. You can have the greatest infrastructure architecture in place, but if your application has some single point of failure, for example, we had a customer that every database access went through a proxy server, and they had one proxy server. They had a bunch of read slaves behind the scenes, and they said, hey, we can handle all this load. Well, yeah, you can, but if that proxy server goes down for whatever reason, you're out. So you do not have high availability by definition because you had that single point of failure. So look at your architecture at all levels and eliminate any single points of failure. And related to that, we recommend that you always place at least one of each component of your architecture, load balancers, app servers, cache servers, databases, whatever it may be, in at least 2 availability zones. Again, that's to increase the redundancy and availability of your application. Now, this next one is more of a budget thing, but if you can, it's a great thing to do, and that's maintain sufficient capacity to absorb any potential failures. So, for example, some of our customers actually run more instances than they need spread across multiple AZs so that if an AZ was to go down, they could pick up that load in the other AZs which are still up and running without having to launch additional instances. Now, granted, not everyone has the budget where they can afford to do that, but if you need a true HA solution, it is definitely something worth exploring. Some cloud providers give you the concept of reserved instances, and a reserved instance basically guarantees that capacity is available for you. So you pay for it ahead of time, and if a region, for example, fails and you have a reserved instance in another region, you know that if you go to that region and spin up a server, there's going to be capacity there for you. We also recommend you always replicate your data across availability zones, and you back up or replicate across the clouds and regions for failover. And our last slide from this section will talk a little bit about that in the disaster recovery model. And as Rafael mentioned, set up alerting, right? Set up monitoring, alerting, and your escalations, these operations to identify problems and before they're problems, right? You want to put some monitoring in place so you can find things before the user sees them, right? So you can hopefully be alerted to them and fix them behind the scenes. And then when possible, design stateless applications. And it's not always possible to realize, but if your app lends itself to a stateless environment, you can then be resilient to reboot and relaunch if instances happen to be transient or go away for whatever reason. All right, so this next slide is sort of a pictorial representation of what we recommend to our customers as far as a high availability multi-AZ deployment. A lot of customers, again, in particular the last few months, have come to us and said, hey, I really want a multi-region. I want a multi-cloud HA solution. And we sit down and we talk to them, and in paper, or in theory, I should say, a multi-cloud scenario looks a lot better than it does in practice. So imagine, if you will, that what you're looking at here, instead of it being different zones of the same cloud, are actually different clouds. Every time your data leaves Cloud 1 and goes to Cloud 2, for example, you're on the public internet, right? That's the wild, wild west. So you need to secure that data. Your security groups mean nothing when you leave a particular region, so you need to worry about the security of your data. Again, since you're on the public internet, you're subject to the latency therein, right? There might be some nodes down, and the beauty of TCP/IP is your packets will get there, but you don't know when, right? So it might be a little while, so there's going to be some latency there. You're also paying public internet rates once you leave that cloud provider's infrastructure, so it can be very costly. There can be latency involved, and there's definitely security involved. So generally when we talk to customers, they say, hey, I really want a multi-cloud HA deployment. They kind of come away going, you know, let's go with a multi-AZ deployment with a solid DR plan, and we'll talk about the solid DR plan next. So anyway, pictorially, what this represents is kind of what the previous slide talked about. You have multiple components. You have load balancer 1 and load balancer 2. They're spread across the AZs. Now what's not shown here is, you know, let's say you're in a region that has 4 AZs. The same concept we would spread across all the available AZs. We just showed 2 here to make it simple. Your server array is going to grow in a weighted fashion across all the availability zones. Again, so if you lose a particular availability zone, you haven't lost, you know, all your eggs aren't in one basket, right? You haven't lost all your baskets. And then what we have here is you have your master database in one zone and your slave in another zone. So if you did happen to lose zone A in this example, you could promote the slave in zone B to master and be up and running again in fairly short order. And now the balloons, that are the little bubbles that are out on the edges, kind of talk a little bit about some other sort of best practices that we talk about. If you are in a cloud that has the concept of block storage, we recommend that you always snapshot that block storage so that you can therefore back up your database so you'll be able to restore it in a readily recover that database if there's an outage. As I talked about, you want to place your slave databases in one or more availability zones. Consider local storage for additional slave database. And this kind of ties into one of the questions that someone had asked about, you know, Rackspace doesn't have the concept of block storage right now. Okay, well then you can go ahead and maybe set up another slave that's using LVM and take LVM snapshots, and you can take those LVM snapshots and upload them anywhere. So if you're in AWS, you could upload it to Cloud Files to have it in Rackspace so that you could go ahead and spin yourself up in Rackspace. And then lastly, the distributed NoSQL databases. If your app lends itself, we've had customers get a lot of advantage of distributed NoSQL databases because you can spread those primary and replica nodes across all the AZs within that particular cloud. All right, so now the last slide we're going to show here is sort of what we recommend as far as the disaster recovery, right? And we call this our multi-cloud warm disaster recovery model. And warm in that there's only one server running in the other cloud, and therefore you have a minimal additional cost. What you see on the left is a separate cloud from what you see on the right. And what's not shown in the diagram but is implied is that in region/cloud 1 over there on the left, you are spread across all the availability zones of that particular region. And there's a slave in a different AZ. It's not shown here, but there is a slave in that different AZ. This DR plan is really if all of region cloud 1 goes down, what can you do? So again, using the RightScale platform and our concept of the server templates and the MCIs, the multi-cloud images we talked about before, is you can essentially clone your deployment and have it in a non-operational state in Cloud 2, ready to go. You're not paying for it, but it's there, it's staged, it's ready to be fired up. And what we're doing here is we have just a single slave database, so you're only paying for that slave database and its attached volume or its attached storage, and you're replicating from the master in the primary region to this slave in the secondary region. So if you do lose all of region Cloud 1, you can quickly promote the slave in region Cloud 2 to be your master, and literally with a click of a few buttons, we have the concept of a launch all in the RightScale dash. You can launch all those additional servers you see, load balancer 2 through in the app array, spin those up in just a couple of minutes, change your DNS so that your site points to load balancer 2 instead of load balancer 1, and you can be up and running again in short order in an entirely different cloud. So this is sort of our generally recommended, this warm DR solution, and as we talked about, it has that minimal additional cost. You're only paying for that one slave server, and it can bring you up fairly quickly. Okay, so with that said, I think that kind of wraps up our main 5 points. We want to talk a little bit about takeaways, and then we'll jump into a few questions here as well. Sort of the takeaway here is, we have the automation and abstraction curve, if you will, right? Back in the good old days, we had the data center concept, and you had to get on the phone and order and procure hardware, and it took a long time to get your infrastructure in place. And then once you had that infrastructure in place and it was racked and stacked and networked by your IT guys, then you had to go in and manually configure your applications, install your packages, install your patches, etc., right? And then there was the cloud, and it got better. And what that allowed us is an automation of the infrastructure. So you can now fire up those servers in a much more efficient and effective and cost-effective manner. But you still had to do that manual app configuration. You still had to log in and install your app and install your patches and all that other fun stuff. Well, now with cloud management tools like RightScale, we provide you the ability to automate that application as well using the server template methodology. So not only do you have the automated infrastructure, you also have the ability to automate your application deployment and therefore get consistent and repeatable results within the servers that you launch. The next steps, we kind of gave a sort of a pseudo, not a very deep dive on the topics we talked about. We have a lot more content available on rightscale.com/infocenter, and this is just an example of some of the webinars you see there. But we also have white papers, we have slide decks from some of the cloud conferences and cloud expos that some of our folks have spoken at. We have forums, we have a whole bunch of additional info, so we would suggest you go ahead and check that out when you get a chance. And then lastly, we talked a little bit earlier about the LAMP all-in-one. So there's a free edition of RightScale. You can sign up, and you can get 3 of these quick wins we've talked about here today. You can get access to through the free edition. You can go ahead and get a dev and test environment, one of these LAMP all-in-ones, or the WordPress all-in-one trial that I talked about. The WordPress all-in-one template that I talked about. That also allows you to see the configuration management tools that Rafael talked about, the server template concept with the write scripts in the boot sequence, operational decommission. And you also can monitor that server as well as look at alerts on it. And if you're interested in the next two, the auto-scaling and HA type stuff, as well as DR that we talked about, we have a VIP trial. Basically it gives you a free test drive, if you will, of all the features of the RightScale platform. And your sales folks can help you out with that. And then lastly, we've got a bunch of tutorials and examples on what we call our supportal, the support.rightscale.com. And what's listed there on the right are just a few of them. There's a whole bunch there, so we recommend that you go ahead and take a look at that. So with that, I guess I'll hand it over to Sarah if she has anything before, and then Rafael and I'll take a quick look at a few of these questions, perhaps.
Yes.
Okay.
So there are multiple questions, and the first one is, or that I see is, I'm going to read it. Our first concern will be, how do we get our system data into the cloud? We're outside the U.S. Currently, our Oracle database has 1.2 terabytes. So, well, yes, it's given the size of the database is a challenge. Now, being outside of the U.S., I don't think it's a concern. Well, now clouds, for example, Amazon provides multiple regions, and 3 of them are outside of the U.S. So it depends where you are. You may want to start playing with, maybe if you're in Europe, playing with the region in EU from Amazon. Now, one idea that could be that take a basically backup of your data and transmit it and put it into some instance on the cloud. Now, it may take a long time for that to happen, but once you have the data there, of course, it's going to be old. Then you can maybe launch a server that can act maybe as a slave. And once you have loaded the database into the slave, maybe you can start doing some replication. Now, it will take some time for that server to be up to sync in time with respect to the master, but then you may suddenly, after a couple of days, you may have a slave that is already sync. If you are new to the cloud, well, just having your data into the cloud and start doing the dev and test and start doing your development so that you can get ready to have a deployment that you know is working in the cloud, then all you have to do is to connect your slave, wait until replication syncs, and after that you can decide to switch into the cloud. Well, I'm just assuming that that's what you want to do. The second question is, how about real-time SNMP feed? I think you're referring to the monitoring data and whether we provide that. Currently we don't, but we support API calls to our monitoring data so that it's possible for you to get either the raw information and to programmatically get that data and analyze it and maybe display it in some other format that you find convenient, or just getting the actual graphs and displaying them in any way that maybe you you want to provide an internal service in your company and leverage all the graphics and monitoring that we do, you can do that through our API. I don't know if you want to take another question, Brian?
Sure. Let's see here. We've got one of the questions here, and it says, are these alerts exportable to standard tools, and if so, in what format? I'm assuming it probably means maybe the monitoring data, so I'll kind of address it from that standpoint. Basically, the way that our monitoring system works is, if any of you are familiar with CollectD, basically we're using CollectD to collect all that monitoring and display all that monitoring data, which comes out in that RRD format, so you can use things like RRD tool, things along those lines. Now, there's kind of two things here. One is that if you have additional metrics that you want to monitor, as Rafael mentioned, we have like 80 different ones that come out of the box, but maybe you have an application metric that you want to monitor. Maybe it's, for example, I'm thinking of a common one, our customers that have these virtual rooms. They have a game, a social game where they have a virtual room, and they want to know how many players are in the room, and that's something they want to monitor. As long as you have the ability to query your application for a particular value and it can spit out a value, we can go ahead, or you or we can go ahead and implement that in a what we call a custom CollectD plugin, and you go ahead and monitor that additional metric as well, and that'll show up in the RightScale dash. Now, what you can also do, and some of our customers have done, is you can go ahead and add your own CollectD server, if you will, to who the data is being broadcast to. We're broadcasting it to our CollectD aggregate servers, if you will, but you can also stream that data out to your server, and some of our customers do that to look at very particular detailed information on a particular metric that they're interested on one or more of their servers. Another question is, how do the load balancers know the status or availability of the app servers located in the other cloud? And that's where it definitely gets tricky, and that's, like I said, why folks that come to us and talk about, hey, this multi-cloud, high availability solution is what I want. That's one of the reasons that they kind of go away, right? Because it's doable, but it's very, very complicated, right? You have to, generally what we would do in that regard is secure that traffic in some way. We've had customers wrap it in an open VPN type solution, but that's why we typically recommend instead is that you have that HA, use multiple availability zones to achieve your HA, and therefore you don't need to worry about app servers in that other cloud. And if bad things happen to the cloud that you're running in, you use your DR solution to go ahead and get yourself up and running in that other cloud.
There's another question that is, how does the Zen server integrate with the RightScale platform? Well, Zen is one of our partners, and they have published in the marketplace some server templates that in a way provide a functionality. So if you connect to the marketplace, you will have access to these server templates, and you can launch them.
Sure, and actually I can throw a little bit more in there, Rafael, just because I've been working with the Zen guys actually even this morning, is that we have what's called the Zen solution pack, which you can find as well, and that's probably not a part of the free edition, that's probably part of the paid edition, but the Zen solution pack allows you to, basically by running a macro, which is something we did not talk about today, but RightScale is the concept of macros, which basically builds out deployments for you. You fill in a few inputs, you click run macro, and it goes ahead and creates a deployment for you. We have this Zen HA macro, and what that will do is it will create you 2 load balancers. It will create you 2 Zen PHP application servers. It will then create a Zen PHP scalable array of application servers, a Zen cluster manager, as well as a MySQL master and slave database, all with the click of basically a button and filling in a few inputs. And what that does for you is that the Zen cluster manager does the session sharing, I can never say that, of the application servers, so that if you do have any application servers that go down for whatever reason, the Zen Cluster Manager can handle that and allocate that session to another server. So that is currently available in the RightScale Dash. We also have the standard solution pack, which does not come with the Cluster Manager and does not come with a slave database, and that's more for dev and test perhaps type environment. But we do have a tight integration and a very close partnership with the folks at Zen.
I think we're starting to reach the end, but let me try to answer a couple of more questions. One is, does template maintains a centralized CMDB of all the individual components that are in the cloud? I think the answer, without going into much detail, is yes. We do that. And then another question is, how is your planning about Cloud Foundry support and OpenShift support on the platform as a service area? Well, we're starting to look into that. In fact, we publish a server template that tries to allow us to work with Cloud Foundry. However, there is a lot of more work to do there. is one area that we're following closely. We have some interactions with them, and we would like to do more. But it's something for the future at this point. I don't know if, Brian, you want to say more about that?
No, what we currently have is as Rafael was alluding to, we do have an integration with them. We have what we call sort of our all-in-one, if you will, integration with the Cloud Foundry. And that's currently available as well in the RightScale platform. Again, that would probably not be a free edition, but that would be available for you to go ahead and play with. We do have continuing work with the folks at VMware to go ahead and expand that offering so that we have the ability to no longer have just an all-in-one, but you'll basically be able to have a scalable array of the Cloud Foundry servers that can then talk to some centralized database or centralized other services as well. So that is something that is still forthcoming. What we have right now is essentially just the all-in-one, but our offering there is just in its infancy. It's only going to grow.
Cool. Thanks, Rafael, and thanks, Brian, and thanks, everyone, for joining us today. We're on the hour right now, so we want to respect everyone's time and call it quits. Thanks again for your time, and we will be sending out, oh yeah, just one other thing I should remind you is that we were recording today's webinar. We just need to do a little bit of compression on that, and we'll be sending it out tomorrow morning to everyone who attended. Also in that email, be on the lookout for it. There is a surplus of resources available for these 5 quick wins. We are linking you to the white papers, to webinar archives, and to resources in our support portal that Brian mentioned earlier. So again, be on the lookout for that. That'll be really helpful in getting started. So thanks again for your time. One other reminder is that next week, third up in our Getting Started in the Cloud series is our webinar with AllinOne, From Zero to Cloud in 60 Minutes. So AllinOne will take us from truly zero to being in the cloud in less than 60 minutes. So if you're not already registered for that, you'll definitely want to check that out. So thanks again for joining us, and have a great day. Bye.